Okay, so for the part D, we call this a phenol. So we draw the phenol. So phenol basically is oxygen H attached to benzene group. So we have electrons next to the pi bond. And remember again, we have hydrogen each corner. So if I move this electron here, move the pi bond here, so the resonance structure would be double bond O H. Now oxygen has 5 electrons. So that means it's positive. These electrons moved over here, so this is negative. You have to remember there's still one hydrogen in this corner. I'm not going to show that, but there's one hydrogen here, hydrogen in each corner. Now this has more resonance structure. So the electron from here, which we're not showing that, we're going to just show it as a negative, can move over here, make a pi bond here. This moves over here. So the new resonance structure would be double bond here, O, H, positive. So this is now negative here. So we can see that we can do the same thing here. Move it over here, move this electron in this corner. So now the new resonance structure, the extra electron or negative would be this corner. We still have double bond OH, positive. And then the bond moved over here, remember? So this is another structure. So this phenol has number of a structure, and this negative charge would be in this corner, this negative, and would be in this corner. When we go to organic 2, you'll see that there's a need or use for this kind of resonance structure. We're going to learn that later on. Okay, so again, it's electron next to the pi. The next one that Dr. Klein is asking us to look at it is E. So we're going to look at the E. So I'm going to move my paper a little bit higher. So E, I'm going to redraw it. So E was carbon, 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 nitrogen, 2 methyl group. Positive here means only, remember, if it was no charge, we'd have 1, 2, 3, 1 hydrogen there. So there is nothing there. There is no hydrogen there. But we have electron here. So this is my E structure. So again, electron next to the positive charge here. So if I move this electron here to make a double bond, so the resonance structure would be carbon, 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 double bond N, methyl group, positive, and a methyl group here. So the positive now went from a carbon to nitrogen. Went from the carbon to nitrogen. So this is a resonance structure for E. So we did the D, we did the E. Let's look at the F now. So I'm going to redraw it here for F. So we have I'm going to redraw it. We have a carbon, carbon. This carbon is positive. So then this carbon now is attached to a nitrogen and it's double bond O. So what are we going to do? So we have to remember something here, that the nitrogen has 1, 2, 3, so they still have 4 and 5. So nitrogen has extra pair of electrons that the structure doesn't show. The structure doesn't show. So if I use a different color, I forgot to use different color, we can move this electron next to a positive charge over here. So the product that we're going to make, the product that we're going to make or the structure that we have, carbon, 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 nitrogen, O. So the O didn't really is not changing. Now nitrogen make a double bond to this carbon. So the nitrogen now is going to be 1, 2, 3, 4 would be positive. So this will be the resonance structure for part, oh, I forgot to write it down, part F or structure F. So we did this 3.